Hi everyone, I'm just going to make an outline for you for everything that is going to be on your test. I would suggest that as you're watching this, you get a pen and paper and you write down the things that I am writing down so that you can use this to study and you don't have to rewatch this video. Of course, if you want to, I'm not sure why you would, but if you want to watch it multiple times, you can. I would write this down exactly as I am writing it down. So the first thing that you need to remember for your test is what an observation is. So hopefully you remember that for observations, you are using one of your five senses. So that could be something that you see, hear, taste, touch, or smell. For our class, the one that we will use most often is seeing. So if you see something happen, that is something that you can say is an observation. They like to ask you how you can extend your senses, and you will do that by using instruments. An instrument can be anything as simple as a ruler. It could be an air pressure gauge, a rain gauge, anything that we would use to help us determine weather variables. They would help us to still make an observation. So if you see something with a definite number, it is still an observation because you would read that number off of the instrument. We also discussed inferences. Remember that inferences are not observations, but they are like a guess that is based off of your observations. So based on an observation. So you see something and then you infer the reason as to why. You could also say an inference is considered a prediction. That's going to be a guess, but it's going to be a guess about something in the future. So examples that we saw for inferences that were also predictions were something to the effect of the damage from the storm is expected to be extensive, or the level of the river will increase after the rainfall, something to that effect. And then also from the very beginning, we talked about classification. So just remember the key words: organized, or group, or grouping, based again on observations. And we discussed several things that we organize or classify in earth science. And we talked about storms and stars, rocks, and minerals, to name a few. So you may see those. Okay, next thing I'm going to talk about is rate of change. So your rate of change is a formula that you have on the first cover of your earth science reference tables. So this is not something you have to memorize, you just have to remember where it is. It does say that it is the change in value over time. So for this formula, it's very important that time always go on the bottom of your fraction. And when you are trying to calculate this, you would put in your change in value, then divide, and then your time on the bottom. For either the top or the bottom of the fraction, if you have two values, change, remember, means that you are going to subtract. And you're going to always do the larger number minus the smaller number so that we don't have negative answers. Please make sure you're reading carefully exactly what, sorry for that, exactly what they want. So the time should always go on the bottom. And if there is a question that has a chart, make sure you are reading exactly what part of the chart you should be looking at. So sometimes they might not ask about the entire chart, but only a portion of it. So just be careful reading for that. So please make sure you have all of this, and I'm just going to change the page. So the next thing I'm going to remind you about is graphing. So for graphing, I feel like our most unique graph that we looked at was a cyclic graph. They refer to events that are cyclic as predictable and repeated. Remember that the graph for cyclic looks something like this, where it goes up and down in a repeated, predictable pattern. And we talked about a bunch of different things in earth science that were cyclic, like seasons, tides, moon phases, and like sunrise or sunset, to name a few. There's more. Also, just remember that you have your direct graph that looks like that. In general, it doesn't always have to be perfectly straight, but in this case, both variables are increasing. You have your indirect graph that looks like this, where one variable is increasing while the other decreases. And then the last graph we looked at was a constant or a static graph, which was a flat line running parallel to your x-axis. Okay, I think we are on to the last portion of what will be on your test, which is density. So please remember lots of important things for density. If your samples, or whatever they're talking about in the question, are made out of the same material, that means they have the same density. Remember that size and shape do not affect the density. If it's made out of the same thing, it has the same density. We did talk about two things that would change the density. So only two will change density, and that's when you change either the temperature or the pressure. Remember that if you increase your temperature, you are making the molecules spread further apart from each other, so there is more space, so you are making it less dense. If you increase your pressure, you are squeezing those molecules together, making it more dense. Okay, also on your reference table, you have your density formula. So density, we all know, is equal to mass over volume. This is, I'm just gonna write ESRT, that's your Earth Science Reference Tables, page 1. And we told you that you should remember to jot down a density triangle, where density is equal to mass over volume. Make sure your mass goes at the top, like the top of a mountain. So now using this, you can create 3 different formulas. If you cover the D for density, you have mass over volume. That's the formula you know already. If you cover the V, you have mass over density. And if you cover your M, you have D next to V. So that is density times volume. So you can use any of those 3 formulas from writing out this density triangle. Remember that for something to be more dense, So if you are more dense, that means that you will sink. Like if you were placed into a fluid that was not as dense. If you were less dense than the fluid, you would float. So that brings us to the last part of density. I just have to change the page because I have no more room. There was one thing that we talked about, which was kind of our exception to our density rules. And hopefully you remember that substance was water. This is also on the front cover of your reference table. So ESRT page 1. It tells you in your properties of water chart that water is most dense as a liquid at 3.98 degrees Celsius, which sometimes they'll just say about 4 degrees Celsius. So water is going to be most dense as a liquid, which is unlike any other earth material. Everything else is going to be most dense, not as a liquid, but as a solid. And I believe that is everything that is on your test. So hopefully you wrote all of this down. If you did not, you are going to write it down now and use this as a study guide. And if you have any questions or concerns, you'll reach out to myself or Miss Ackerman. All right, have a good day.